Hello everyone, this is Bharati Tare, Assistant Professor, Govindrao Nikam College of Pharmacy, Savardi. In this video, you will learn about aromatic heterocyclic compounds. Dear learners, by the end of this video, you will be able to classify aromatic heterocyclic compounds. You also will be able to justify aromaticity of furan, pyrrole and thiophene. As well, you can compare and contrast aromaticity amongst benzene, furan, pyrrole and thiophene. Here are some examples of aromatic heterocycles. Just observe them carefully and try to group them with the similar structural features. And note down the names and structures belonging to the same group. Pause the video and list the compounds belonging to similar structural features. Let us check whether the compounds grouped by you matches with the mine listed compounds. If you have finished listing out the groups, play the video and let us check. Yes, one common structural property is associated with all compounds, that is, all compounds are aromatic. Some of the compounds are 5-membered rings with single heteroatom. For example, furan, pyrrole, thiophene. Whereas, some of the compounds are 5-membered rings with 2 heteroatoms. Ring size of this class is same, but the number of heteroatoms are 2. For example, imidazole, pyrrole, thiazole, isothiazole, oxazole, isoxazole. Some compounds are 6-membered rings with single heteroatom. Ring size is different than the above classes. For example, pyridine. Some compounds are 6-membered rings with 2 heteroatoms. For example, pyrimidine, pyrazine. Some of the compounds are fused rings with 1 or 2 heteroatoms in it. For example, quinoline, isoquinoline, indole, etc. Now from that, one of the class 5-membered aromatic heterocycles with single heteroatom. The compounds belonging to this class, namely furan, thiophene and pyrrole. What is the similarity in all these structures? All these structures are similar to each other except for the fact that pyrrole has a lone pair and 1 nitrogen-hydrogen bond, whereas thiophene and furan, there are 2 lone pairs of electron on sulfur and oxygen. All the atoms in above structure are sp2 hybridized. Dear learners, furan, thiophene and pyrrole all are aromatic compounds. Aromaticity is one of the significant property which decides the stability and reactivity of organic compounds, and hence it becomes essential to check, decide and justify aromaticity of organic compounds. Hence, we need to justify the aromaticity of furan, pyrrole and thiophene. Before that, I will like to ask you to list out the properties, that is structural features, which do decide aromaticity. Again, pause the video and list out the structural features which decide aromaticity. Once you finish, play the video. Yes, congratulations if you have predicted Haeckel's rule. To be aromatic, molecule should be cyclic, planar, and there should be continuous delocalization of 4n plus 2 pi electrons. Let us check whether furan, pyrrole and thiophene do obey Haeckel's rule. Here is the molecular orbital picture of pyrrole, furan and thiophene. What do you observe in this? All atoms in these structures are sp2 hybridized. So all the 4 carbon atoms and the heteroatom being sp2 hybridized lie in the same plane. And therefore all these 3 structures are planar. If more carefully you observe this structure, you can see the green colored orbital on each atom in all these heterocycles. What are these green colored orbitals? These are unhybridized p orbital on carbon and heteroatom. The unhybridized p orbital of carbon do contain single electron which contribute in the pi bond formation, whereas the unhybridized p orbital on heteroatom contains a lone pair of electron which is in conjugation with pi bonds, and hence this lone pair of electron and 4 electrons from 2 pi bonds forms a sextate. That is, they all have an aromatic sextate, that is 6 pi electrons are continuously delocalized over the ring. These electrons are in the unhybridized p orbital as we discussed earlier of each atom perpendicular to the plane of the ring. The double bonds and the lone pair involved in the sextate are in conjugation. These compounds are cyclic too, and hence furan, thiophene and pyrrole do obey Haeckel's rule and are aromatic heterocycles. Here are the 4 aromatic compounds: benzene, thiophene, pyrrole and furan. If you see the aromaticity given over here, benzene is most aromatic compound, than that of thiophene, than that of pyrrole, than that of furan. Furan is least aromatic. Why it is so? Which factor decides the aromaticity amongst all these compounds? Yes, all the pi electrons in benzene are totally involved in formation of aromatic sextate. If you draw the resonance structure for benzene, both the structures are equivalent, and hence benzene is more aromatic than thiophene, pyrrole and oxygen containing furan. Whereas in other molecules there is a presence of heteroatom, that is nitrogen, sulfur and oxygen. These are more electronegative than carbon. What is electronegativity? Tendency to pull the electrons towards itself, and therefore these heteroatoms, being more electronegative than carbon, pull the electron cloud towards themselves, and thus there is an uneven charge distribution. And this uneven charge distribution leads to decrease the aromaticity of these heterocycles. More the electronegativity of heteroatom, less is the aromaticity of the compound. Oxygen is the most electronegative amongst sulfur, nitrogen and oxygen, and so furan is least aromatic heterocycle. Sulfur is less electronegative. Also, the 3s and 3p electrons are the valency electrons in sulfur atom as opposed to 2s and 2p in oxygen and nitrogen. Thus, the above trend depends on electronegativities of the heteroatom in the structure. The above trend in the sense benzene is most aromatic, whereas furan is least aromatic compound. Dear learners, I hope you must have understood the classification of aromatic heterocycles. As well, you can justify the aromaticity amongst furan, pyrrole and thiophene, and you also can now compare and contrast the aromaticity between benzene, pyrrole, furan and thiophene. Dear learners, please rewind, revise and retain the concept so that you can enjoy learning of reactivity and reactions of these aromatic heterocycles in next video. Thank you.